On the morning of June 6, 1944, Private First Class Leonard Schroeder of the 502nd Parachute Infantry Regiment stood in the open door of a C-47 aircraft at 1,200 feet above Normandy. Wind tore at his face. The engines roared. Below him, tracer fire streaked upward through the darkness like deadly fireflies seeking their targets. He could see the muzzle flashes from German anti-aircraft guns, could hear the metallic pings as shrapnel struck the fuselage. The red light beside the door glowed. His hands gripped the static line. 42 kilograms of equipment dragged at his body. Ammunition, grenades, rations, entrenching tool, reserve parachute, main parachute. Everything a paratrooper needed to fight behind enemy lines for 72 hours without resupply. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The light turned green. Schroeder jumped into the night. The propeller blast caught him, spun him sideways. He counted. 1,000, 2,000, 3,000. The static line jerked taut, ripped the deployment bag from his back. The parachute canopy exploded open above him with a sharp crack that he felt through his entire body. The opening shock was violent enough to knock the wind from his lungs. For a moment, everything went silent except for the whistle of air through the suspension lines. Then he looked up. The canopy above him was white, solid white, not the traditional khaki of silk parachutes he had trained with at Fort Benning, but bright, reflective, unmistakable white, a nylon parachute, one of the new ones. The material that the Quartermaster Corps had started issuing just months earlier. Schroeder had no way of knowing it that morning, but the parachute carrying him toward the French countryside represented one of the most critical supply chain victories of the Second World War, a victory that had nothing to do with tanks or bombers or naval supremacy. This was a victory of industrial chemistry, emergency procurement, and desperate improvisation. The nylon parachute above Leonard Schroeder's head existed only because 19 months earlier, the United States military had faced an absolute catastrophe in parachute production, a crisis so severe that it threatened to cancel every planned airborne operation for the remainder of the war. The crisis began on December 7, 1941, when Japanese aircraft struck Pearl Harbor. Within hours, the United States was at war. Within days, the Quartermaster Corps in Washington realized they had a problem that would reshape American airborne doctrine. Every parachute in the United States inventory was made from silk, Japanese silk. The statistics were damning. In 1941, the United States imported approximately 70% of its silk from Japan. The remaining 30% came from China, which was already under Japanese occupation. American silk production was negligible. The domestic silk industry had collapsed during the Great Depression. The few remaining American silk mills produced luxury fabrics for evening gowns and neckties, not industrial-grade material suitable for parachutes. Parachute silk required specific characteristics. It needed to be woven in a particular weave pattern that balanced strength with flexibility. The thread count had to be precise. Too loose, and the canopy would allow too much air to pass through, slowing deployment and increasing descent rate. Too tight, and the fabric became heavy and difficult to pack. The silk had to be treated with specific finishing processes to make it resistant to mildew, rot, and degradation from exposure to ultraviolet light. Japanese silk met all these requirements perfectly. The silk mills in Japan had spent decades refining their processes. They understood the chemistry of silk production, the biology of silkworm cultivation, the engineering of industrial looms. American parachute manufacturers had become entirely dependent on Japanese material. Colonel William Yarborough, who commanded the 501st Parachute Infantry Battalion at Fort Benning in 1941, later testified before Congress about the immediate impact of the silk cutoff. His unit had been scheduled to receive 500 new parachutes in January 1942. The shipment never arrived. The Quartermaster Corps had no silk. Production stopped completely. By February 1942, the United States military had approximately 45,000 parachutes in inventory. This sounds like a substantial reserve until one considers the expansion plans for American airborne forces. The War Department had authorized the creation of 5 airborne divisions. Each division required approximately 13,000 parachutes for its initial equipment. Another 6,000 parachutes per division were needed for training. That was 95,000 parachutes just for the 5 airborne divisions, plus additional thousands for aircrew emergency parachutes for every bomber and fighter aircraft in production. The mathematics were brutal. At current consumption rates, the existing inventory of 45,000 parachutes would be exhausted by summer 1942. After that, there would be no new parachutes, no training jumps, no combat operations. The entire concept of American airborne warfare would become impossible. The Quartermaster Corps explored alternatives desperately. They investigated using cotton, but cotton fabric absorbed water and became heavy when wet. A paratrooper landing in a marsh or river with a waterlogged cotton parachute would sink. They examined rayon, but rayon lost strength when damp. The British had experimented with rayon parachutes in North Africa and reported catastrophic failure rates during the rainy season. Linen was too stiff and difficult to pack. Canvas was too heavy. Every natural fiber had problems that made it unsuitable. The crisis intensified through spring 1942. Training commands began rationing parachutes. Paratroopers at Fort Benning were limited to 4 training jumps instead of the standard 7 before being certified for combat duty. This was dangerous. Parachuting was an unnatural activity that required practice. Muscle memory had to be developed. Men needed to learn how to exit the aircraft properly, how to control their body position during free fall, how to prepare for landing. 4 jumps was barely adequate. By May 1942, some training units were using the same parachutes for multiple jumps per day. Riggers would repack a parachute immediately after landing and load it back onto the aircraft for the next student. This violated every safety protocol. Parachutes needed inspection between uses. The fabric had to be examined for tears or weak spots. The suspension lines had to be checked for fraying. The connector links had to be tested. Rushing through repacking increased the risk of malfunction. The situation became desperate enough that Major General William Lee, commanding general of the Airborne Command, sent a classified memorandum to the War Department in June 1942, stating bluntly that without an alternative to silk, the United States would need to abandon airborne operations entirely. The British could supply limited numbers of parachutes, but British production was already strained, supporting their own airborne forces. The Soviets had parachute production capacity, but Soviet parachutes used different harness designs and were not compatible with American aircraft or training methods. The solution came from an unexpected source: the DuPont Corporation in Wilmington, Delaware. DuPont was a chemical company that had been experimenting with synthetic polymers since the 1920s. In 1935, a DuPont chemist named Wallace Carruthers had invented a synthetic fiber created by forcing molten polymer through tiny holes to create long, continuous filaments. The fiber was strong, lightweight, elastic, and resistant to water, mildew, and most chemicals. DuPont called it nylon. It was chosen because it sounded modern and scientific. Nylon was introduced commercially in 1938, primarily marketed for women's stockings. Nylon stockings became enormously popular. They were more durable than silk stockings, less expensive, and retained their shape better after washing. By 1941, DuPont was producing 4 million pounds of nylon filament annually, almost entirely for the consumer hosiery market. When the silk crisis hit the Quartermaster Corps in early 1942, someone at the War Department remembered nylon. The material had the right properties on paper. It was strong. It was lightweight. It was manufactured domestically. The question was whether it could actually function as a parachute material. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Quartermaster Corps contacted DuPont in March 1942 and requested samples of nylon fabric woven to parachute specifications. DuPont responded within 2 weeks. They sent fabric samples to the parachute branch of the Quartermaster Corps at Philadelphia Quartermaster Depot for evaluation. The initial tests were promising. Nylon was actually stronger than silk by weight. A nylon fabric of the same thickness as silk parachute material had approximately 20% greater tensile strength. This meant a nylon parachute could theoretically be made from thinner, lighter fabric and still maintain the same strength as silk. But strength alone was not sufficient. The fabric had to perform correctly during deployment. A parachute canopy must open in a controlled manner. If it opens too quickly, the opening shock can injure the paratrooper or tear the canopy. If it opens too slowly, the paratrooper does not decelerate adequately before hitting the ground. Silk had decades of proven performance. Nylon was unknown. The Quartermaster Corps needed human testing. They needed someone willing to jump with an experimental parachute made from untested material over hostile territory. They found that person at the Pioneer Parachute Company in Manchester, Connecticut. Adeline Gray was 24 years old in 1942. She had been jumping for 5 years, working as a parachute rigger and test jumper at Pioneer. Gray was not military. She was a civilian employee. But she was exceptionally qualified. She had completed over 100 jumps. She held a pilot's license. She had worked as a barnstormer, performing aerial stunts at county fairs and air shows across New England. She understood parachutes intimately. She had packed thousands of them. She knew what could go wrong. When Pioneer Parachute Company received the contract to manufacture the first test batch of nylon parachutes, Gray volunteered to test them. On June 6, 1942, exactly 2 years before D-Day, she drove to Brainerd Field in Hartford, Connecticut, and boarded a single-engine aircraft for the first human test jump of a nylon parachute in history. The test jump was documented by Pioneer engineers, by representatives from the Quartermaster Corps, and by local newspaper photographers. Everyone understood the significance. If this test succeeded, it could solve the silk crisis. If it failed, if the nylon parachute malfunctioned, if Gray was injured or killed, the program would be cancelled immediately. Gray climbed to 3,000 feet. The pilot leveled off. Gray moved to the door. She checked her harness one final time. The risers connected to a canopy made from white nylon fabric, 28 feet in diameter, 24 gauze. The same design specifications as standard military silk parachutes, but constructed entirely from synthetic material. She jumped. The static line deployed the canopy. For 3 seconds, Gray was in freefall, watching the deployment bag fall away, watching the suspension line stretch out behind her. Then the canopy caught air. The opening was sharp, clean, exactly as designed. The nylon fabric snapped into a perfect hemisphere above her. Gray looked up and saw a solid white canopy, fully inflated, holding together under load. She checked the suspension lines. All present, no tangles. The descent rate felt normal. She landed in an open field, executed a proper parachute landing fall, rolled to absorb the impact. She stood up, unhurt, and signaled to the ground crew. The parachute had functioned perfectly. The first nylon parachute jump in history was successful. Gray completed 3 more test jumps that day. Each jump was successful. The nylon parachutes performed as well as silk. Actually, they performed slightly better. The nylon fabric was more elastic than silk, which meant the opening shock was slightly softer. The canopy recovered its shape more quickly after deployment. The fabric showed no signs of stress or degradation after multiple uses. The Quartermaster Corps authorized immediate production. DuPont converted its nylon manufacturing capacity from consumer products to military contracts. Women's nylon stockings disappeared from American stores overnight. Every pound of nylon filament was redirected to parachute production. Pioneer Parachute Company hired thousands of additional workers and converted its entire facility to nylon parachute manufacturing. Production ramped up through summer and fall 1942. The first nylon parachutes reached military units in October. The 501st Parachute Infantry Battalion at Fort Benning received a shipment of 300 nylon parachutes in November. Colonel Yarborough ordered immediate field testing. His paratroopers jumped with nylon parachutes and reported no significant differences from silk except for the distinctive white color. But scaling production from hundreds to hundreds of thousands revealed unexpected challenges. Nylon required different manufacturing processes than silk. The weaving machinery had to be adjusted. The thread tension settings were different. The finishing treatments were different. Silk parachutes were typically treated with a water-resistant coating and a mild fungicide. Nylon did not need these treatments, but it did require special handling to prevent static electricity buildup during manufacture. Quality control became critical. A parachute malfunction could kill a soldier. Every parachute had to be inspected rigorously before shipment. Pioneer Parachute Company established inspection protocols where every seam was examined under magnification. Every suspension line was tested for proper strength. Every connector link was proof-loaded. Any defect, no matter how minor, resulted in rejection. The rejected parachute was stripped down for parts. The fabric was salvaged for other uses. Nothing was wasted. By early part 1943, American parachute production had recovered from the silk crisis. Monthly output reached 15,000 parachutes. Half were nylon. Half were still silk, made from rapidly diminishing stockpiles of pre-war inventory. The Quartermaster Corps preferred to issue silk parachutes for training and reserve nylon for combat operations, but this policy became impossible to maintain as silk stocks ran out completely by mid-1943. The transition to all nylon production was completed by September 1943. From that point forward, every new American parachute was made from nylon. The material proved superior to silk in almost every measurable way. Nylon was stronger. It was more resistant to rot and mildew. It maintained its strength when wet. It packed more easily because the fabric was slightly more slippery than silk. It was less expensive to manufacture because nylon could be produced domestically without depending on imported raw materials. The only disadvantage of nylon was visibility. The white color made paratroopers more conspicuous during daylight jumps. German and Japanese forces could see nylon parachutes more easily against dark backgrounds like forests or urban areas. The Quartermaster Corps attempted to dye nylon parachutes, olive drab or camouflage patterns, but the dyes affected the fabric's strength characteristics. After several test failures, the military decided white nylon was acceptable. Airborne operations typically occurred at night or during periods of limited visibility anyway. By December 1943, American parachute production had reached 25,000 units per month. DuPont had expanded its nylon manufacturing capacity dramatically. New factories came online in Virginia, North Carolina, and Tennessee. Each facility employed thousands of workers, predominantly women, who operated the complex chemical processing equipment required to transform raw materials into nylon polymer, then extrude the polymer into filaments, then weave the filaments into fabric. The Pioneer Parachute Company in Manchester, Connecticut, became the largest parachute manufacturer in the world. At peak production in early 1944, nearly 3,000 workers at Pioneer produced 300 parachutes per day. The facility operated 3 shifts, 24 hours a day, 7 days a week. Women comprised approximately 80% of the workforce. Many were wives or mothers of servicemen. They understood that their work directly impacted survival rates. The manufacturing process was labor-intensive and required precision at every stage. Nylon fabric arrived at Pioneer in large rolls, each containing hundreds of yards of material. The fabric was first inspected on illuminated tables where workers examined every square inch for flaws. Any imperfection in the weave, any thin spot, any irregularity resulted in that section being marked and cut out. After inspection, the plein perfect fabric was cut into panels according to precise patterns. Each gore of a standard 28-foot parachute canopy consisted of multiple panels sewn together. The sewing had to be perfect. Parachute seams were subjected to tremendous stress during opening. A weak seam could tear, causing catastrophic canopy failure. Pioneer used industrial sewing machines capable of producing stitches with breaking strengths exceeding 1,000 pounds. Each seam was sewn multiple times, creating redundant load paths. After the gauze were sewn, they were assembled into the complete canopy. 24 gauze for a standard personnel parachute. Each gore was carefully aligned and sewn to its neighbours. The apex of the canopy, where all the gauze met, was the highest stress point. This area received extra reinforcement. Multiple layers of fabric were sewn together. Heavy webbing was added to distribute loads. The suspension lines were attached next. Each line had to be exactly the same length. Variations as small as 1 inch could cause the canopy to deploy asymmetrically, resulting in dangerous oscillations or uncontrolled spinning. The lines were made from braided nylon cord with braking strengths of 500 pounds each. A standard parachute had 28 suspension lines, providing a total load capacity far exceeding the maximum forces generated during normal deployment. After assembly, each parachute underwent final inspection. Inspectors checked every seam, every stitch, every suspension line connection. They measured the canopy diameter. They verified the vent hole at the apex was the correct size. They tested the connector links. They examined the deployment bag. Only after passing final inspection was a parachute approved for military use. The approved parachute was then packed according to strict protocols. Packing a parachute was an art and a science. The canopy had to be folded in a specific sequence that allowed it to deploy smoothly when the static line pulled the deployment bag away. The suspension lines had to be carefully arranged so they would not tangle during deployment. The entire assembly was placed in a deployment bag and secured with breakaway ties that would release under the proper force. Every parachute rigger at Pioneer Parachute Company took a pledge before beginning work. The rigger's pledge stated, "I will pack every parachute as though I am to jump with it myself, and will stand ready to jump with any parachute which I have certified as properly packed." This was not merely symbolic. Riggers at military depots were required to periodically jump parachutes they had packed as a quality control measure. A rigger who packed carelessly was literally risking his own life. The nylon parachutes produced at Pioneer and other American factories through 1943 and early 1944 accumulated in military depots across the United States and Great Britain. The build-up for Operation Overlord, the invasion of Normandy, required unprecedented quantities of equipment. The plan called for dropping approximately 13,000 American paratroopers on the night before D-Day. Each paratrooper needed a main parachute and a reserve parachute. That was 26,000 parachutes just for the initial assault. Additional thousands were needed for training, for replacements, for follow-on operations. The 82nd Airborne Division and the 101st Airborne Division began intensive training for the Normandy operation in early 1944. Both divisions were stationed in England, conducting practice jumps over the British countryside. The training revealed something that had not been apparent in earlier operations. The nylon parachutes were noticeably different from the silk parachutes most paratroopers had trained with in the United States. Veterans who had jumped both silk and nylon reported that nylon canopies deployed slightly faster. The fabric was more slippery than silk, which meant it packed more densely and extracted from the deployment bag more quickly. This translated to a fractionally shorter freefall time between exiting the aircraft and the canopy fully opening. For a paratrooper jumping at 1,200 feet, the standard altitude for combat operations, this difference was measured in fractions of a second. It was barely perceptible. But those fractions of a second mattered. At 1,200 feet, a paratrooper in freefall descends at approximately 120 miles per hour. Every tenth of a second represents nearly 18 feet of altitude. If a nylon parachute deployed even half a second faster than a silk parachute, that was nearly 90 feet of additional altitude before the canopy fully opened and began decelerating the jumper. 90 feet of extra altitude meant more time to assess the landing zone, more time to identify obstacles like trees, buildings, or water, more time to steer toward a clear area using the parachute's limited maneuverability, more time to prepare for landing impact. In combat conditions, with anti-aircraft fire, with strong winds, with poor visibility, that extra time could mean the difference between a successful landing and a fatal one. The training jumps in England through spring 1944 provided thousands of data points. Paratroopers jumping with nylon parachutes consistently reported slightly softer opening shocks, slightly faster deployments, and slightly better overall performance compared to their memories of silk parachutes. The differences were subtle but consistent. The Quartermaster Corps collected injury reports from training jumps and noticed a slight reduction in deployment-related injuries among units using nylon parachutes. Twisted ankles, compression fractures, and back injuries from hard landings occurred marginally less frequently. The data was not dramatic enough to publish in official reports, but it was significant enough that experienced jumpmasters noticed the pattern. By May 1944, as D-Day approached, essentially every parachute issued to American airborne forces was made from nylon. The silk era was over. The transition had happened so quickly that many paratroopers were not even aware of it. To them, a parachute was a parachute. White nylon had simply become the standard. The German military, meanwhile, had experienced its own parachute crisis. Germany had never depended on Japanese silk as heavily as the United States. German parachutes in the early war years were made from silk sourced from Italy and from German domestic production. But by 1943, silk was becoming scarce for Germany as well. The Italians switched sides in September 1943, cutting off that supply. German silk production was limited. The Germans experimented with rayon as a substitute. Rayon was readily available from German chemical plants, but rayon parachutes had problems. The material degraded when exposed to moisture. German paratroopers reported that rayon parachutes stored in damp conditions would lose strength over time. Canopies would develop weak spots, suspension lines would fray. The failure rate was higher than silk. German parachute doctrine also differed fundamentally from American and British practice. German paratroopers jumped from lower altitudes, typically between 300 and 500 feet. This allowed less time for enemy ground fire to target descending paratroopers, but it also meant there was virtually no margin for error. A parachute malfunction at 400 feet was almost certainly fatal. There was no time to deploy a reserve parachute. There was barely time to realize something had gone wrong before impact. The low-altitude jumping doctrine meant German paratroopers were extremely dependent on parachute reliability. When rayon parachutes began showing higher failure rates, German airborne operations became significantly more dangerous. By 1944, the German military had essentially abandoned large-scale airborne operations. The last major German parachute assault was the invasion of Crete in May 1941. After that, German airborne forces were primarily employed as elite ground infantry, not as parachute troops. The Allies, by contrast, were preparing for the largest airborne operation in history. Operation Overlord called for 3 airborne divisions to drop behind the Normandy beaches. 2 American divisions, the 82nd and 101st, would secure the western flank near Utah Beach. 1 British division, the 6th Airborne, would secure the eastern flank near Sword Beach. Together, these forces represented more than 20,000 paratroopers. The operation was scheduled for early June 1944. Weather conditions had to be right. The moon had to provide adequate light for navigation. Tides had to be favorable for the amphibious landings. The window was narrow. General Dwight Eisenhower, Supreme Commander of Allied Forces, postponed the invasion from June 5th to June 6th due to poor weather. Even on June 6th, conditions remained marginal. High winds, low clouds, choppy seas. The decision to proceed was made on the evening of June 5th. At airfields across southern England, paratroopers of the 82nd and 101st Airborne Divisions boarded C-47 transport aircraft. Each man carried approximately 90 pounds of equipment. Main parachute on the back, reserve parachute on the chest, rifle, ammunition, grenades, rations, entrenching tool, gas mask, first aid kit. Some carried additional specialized equipment, demolition charges, machine gun components, mortar rounds. The weight was almost unbearable. Getting into the aircraft required assistance. Men had to be pushed and pulled through the door. Once inside, They sat shoulder to shoulder on metal benches that ran along both sides of the fuselage. 20 paratroopers per aircraft, 432 aircraft in the American drops, nearly 9,000 American paratroopers in the first wave. The aircraft took off shortly before midnight. They formed up into tight formations and turned toward France. The flight across the English Channel took approximately 2 hours. As they approached the French coast, German anti-aircraft batteries opened fire. Searchlights swept the sky. Tracer rounds arced upward. 88mm flak shells burst among the formations, sending shrapnel tearing through thin aluminum fuselages. Pilots took evasive action. The tight formations broke apart. Aircraft scattered across the night sky, climbing, diving, turning to avoid the flak. Inside the C-47 seconds, paratroopers were thrown against each other, against the walls, against the floor. The red light came on. Stand up and hook up. The men struggled to their feet, dragging their equipment. They hooked their static lines to the overhead cable, running the length of the aircraft. The jump masters shouted commands that were barely audible over the roar of engines and the crack of exploding flak. Check equipment. Sound off for equipment check. 13 OK, 12 OK, 11 OK. The count came forward. Everyone ready. But the aircraft were no longer where they were supposed to be. The carefully planned drop zones were scattered across miles of Norman countryside. Go. Men shuffled toward the door and jumped into the darkness. Private First Class Leonard Schroeder exited his aircraft over what he believed was Drop Zone C near Sainte-Mère-Église. He had no way of knowing the pilot had veered 3 miles off course to avoid a concentration of flak batteries. Schroeder's static line deployed his nylon parachute. The canopy opened cleanly above him. He looked down and saw nothing but darkness punctuated by muzzle flashes. The descent felt eternal. Wind pushed him sideways. He could hear other aircraft overhead, could see other parachutes deploying around him, white canopies glowing in the moonlight. Tracer fire streaked through the formations. Some parachutes collapsed suddenly as bullets tore through the fabric. Men screamed as they fell. Schroeder hit the ground hard in a ploughed field. The impact drove the air from his lungs. He executed his parachute landing fall by instinct, rolling to distribute the shock. He lay still for a moment, checking for injuries. Nothing broken. He had landed in German-occupied France, alive, with a functioning parachute made from synthetic fiber created in an American chemical laboratory 3 years earlier. Around him, thousands of other paratroopers were landing across the Cotentin Peninsula. The drop was chaos. Units were scattered over an area of hundreds of square miles. Men landed in fields, in marshes, in villages, in trees, on rooftops. Some drowned in flooded areas the Germans had deliberately inundated as a defensive measure. Some were shot during descent. Some broke bones on landing, but the vast majority landed safely with functioning parachutes. The American Airborne divisions suffered approximately 2,500 casualties on D-Day. This included killed, wounded, and missing. The casualty rate was roughly 18%. This was high by any measure, but it was far lower than the predictions. Air Marshal Trafford Leigh-Mallory, Commander-in-Chief of Allied Air Forces, had predicted casualties as high as 70% for glider troops and 50% for paratroopers. He had recommended cancelling the airborne operation entirely. General Eisenhower overruled him. The airborne forces were essential to the invasion plan. They had to secure the causeways leading off Utah Beach. They had to capture key crossroads and bridges. They had to disrupt German reinforcements. Without the airborne drops, the amphibious assault would be significantly more dangerous. The prediction of 50 to 70% casualties proved wrong. Multiple factors contributed to the lower-than-expected losses. The dispersion of the drops actually helped in some ways. The scattered landings confused the German defenders. Small groups of paratroopers appeared everywhere simultaneously, creating the impression of a much larger force. German commanders could not determine where the main effort was concentrated because there was no main effort. Everything was everywhere. But equipment performance also mattered. The nylon parachutes functioned reliably under extraordinarily difficult conditions: high winds, low altitude, evasive maneuvers by pilots, Anti-aircraft fire. Despite all these challenges, the malfunction rate remained low. Most paratroopers who exited their aircraft successfully reached the ground alive with functioning parachutes. Staff Sergeant Malcolm Brannan of the 505th Parachute Infantry Regiment, 82nd Airborne Division, later testified in after-action reports that his entire stick of 18 men landed safely despite their aircraft taking multiple hits from German 20mm cannon fire. The fuselage was perforated. One engine was smoking. But every man got out, every parachute deployed, everyone reached the ground. Captain Charles Shettle of the 502nd Parachute Infantry Regiment, 101st Airborne Division, assembled a mixed group of 82 men from various units on D-Day morning. They had been scattered across several miles during the drop. None had landed in their assigned drop zones, but they had all landed alive with working equipment. Shettle led this improvised force to capture and hold one of the causeways off Utah Beach until relieved by the 4th Infantry Division pushing inland from the beaches. The paratroopers accomplished their mission despite the chaos. By the end of D-Day, all 4 causeways off Utah Beach were in American hands. The town of Sainte-Mère-Église was secured. Key bridges over the Murderay River were captured. German reinforcements were delayed and disrupted. The western flank of the invasion was protected. The amphibious forces at Utah Beach suffered relatively light casualties and pushed inland rapidly, linking up with the scattered airborne units. The success of the airborne operation validated the massive investment in parachute production. The crisis that began in December 1941, when Japanese silk became unavailable, had been overcome through industrial innovation, emergency procurement, and the willingness of companies like DuPont and Pioneer Parachute Company to rapidly scale production of an untested material. The numbers tell the story. Between June 1942 and June 1944, American manufacturers produced approximately 400,000 parachutes. Virtually all were made from nylon. These parachutes equipped 5 airborne divisions, provided emergency parachutes for tens of thousands of aircraft crew members, and supported multiple combat operations across Europe, North Africa, and the Pacific. The German military never solved its parachute material crisis. Rayon remained the standard German parachute material through the end of the war. The higher failure rate and reduced reliability contributed to Germany's abandonment of large-scale airborne operations after Crete. German paratroop divisions fought primarily as ground infantry from 1942 onward, their specialized training and equipment largely wasted. The Japanese military continued using silk parachutes throughout the war. Japan had abundant silk production domestically, but Japanese airborne doctrine emphasized small-scale special operations rather than large division-level drops. The Japanese never conducted airborne operations on the scale of Operation Overlord. Their largest airborne operation was the assault on Palembang in February 1942, involving approximately 700 paratroopers. After that, Japanese parachute forces were primarily used for small raids and infiltration missions. The British military transitioned to nylon parachutes, somewhat later than the Americans. British parachute production continued using silk from Commonwealth sources through 1943. India was a major silk producer, and Britain maintained access to Indian silk throughout the war. But by late 1943, Britain was also converting to nylon as the material's advantages became apparent. British parachute riggers reported that nylon was easier to pack, more resistant to damage, and more consistent in performance. The French airborne forces, which began forming in North Africa in 1943, were equipped entirely with American nylon parachutes, provided through Lend-Lease. French paratroopers participated in Operation Dragoon, the invasion of southern France in August 1944, jumping with nylon parachutes manufactured at Pioneer Parachute Company in Connecticut. The Soviet Union developed its own synthetic parachute materials independently. Soviet chemists created a nylon-like polymer they called capron. Soviet parachute production converted from silk to capron in 1943. The Soviets conducted large-scale airborne operations on the Eastern Front, though these are less well documented in Western sources than American and British operations. After the war, silk parachutes disappeared entirely from military service. Nylon became the universal standard. The material's advantages were too significant to ignore. Every military in the world adopted nylon parachutes. Silk parachutes became museum pieces, relics of an earlier era. The wartime nylon parachutes had another legacy. After the war ended in 1945, millions of surplus parachutes flooded civilian markets. The parachutes were sold as war surplus for a few dollars each. People bought them for the fabric. Nylon was still scarce in the civilian economy. It would be several years before DuPont could fully convert back to consumer production. Women made dresses from parachute nylon. The white fabric could be dyed. It took color reasonably well. Parachute wedding dresses became common in 1946 and 1947. Brides whose fiancés had served in airborne units sometimes specifically requested that their wedding dresses be made from the parachute that had saved their husband's life. These dresses carried deep symbolic meaning. The same material that had brought a soldier safely through combat now clothed his bride on their wedding day. Pilots made clothing from parachute, silk, and nylon. The lightweight, wind-resistant fabric was ideal for flying jackets. Surplus parachute material was used for tents, for tarpaulins, for awnings, for dozens of practical applications. Nothing was wasted. The country that had mobilized every resource for war found uses for every scrap of material once peace returned. Leonard Schroeder, who jumped into Normandy on D-Day with a nylon parachute, survived the war. He returned to his home in Wisconsin in November 1945. He kept his parachute. Years later, he donated it to the Airborne Museum at Fort Benning, where it remains on display. The white nylon canopy is faded now, yellowed with age, but still intact. The suspension lines are still strong. The connector links show the wear of a single combat jump, but they remain functional. The museum label identifies it as a T5 parachute, standard American airborne equipment from 1943 through 1945, 28-foot diameter. Nylon construction, manufactured by Pioneer Parachute Company, Manchester, Connecticut. Date of manufacture, March 1944. Used in combat, June 6, 1944, Normandy, France. That parachute represents one of approximately 13,000 that carried American paratroopers into France on D-Day. It is one of approximately 400,000 nylon parachutes manufactured during World War II. It is a physical artifact of the crisis that began in December 1941, when Japanese silk became unavailable, of the desperate search for alternatives, of Adeline Gray's test jump in June 1942, of the massive industrial mobilization that followed. The story of nylon parachutes in World War II is ultimately a story about logistics and industrial capacity. Wars are won by armies, but armies depend on supply chains. The ability to manufacture, distribute, and maintain equipment determines what operations are possible. When the silk supply was cut off, the United States faced a choice: abandon airborne operations entirely or find an alternative. They found nylon. The decision to develop nylon parachutes required coordination between military procurement officers, chemical engineers, textile manufacturers, and parachute riggers. It required testing under realistic conditions. It required accepting risk. Adeline Gray risked her life, testing an experimental parachute. The first paratroopers to jump with nylon in combat were testing the equipment under the most demanding conditions imaginable. The material proved reliable. Nylon parachutes functioned as well as silk, in many respects better than silk. They enabled the largest airborne operation in history. They contributed to the success of the Normandy invasion. They demonstrated that American industrial capacity and scientific innovation could solve problems that initially appeared insurmountable. The Germans had superior tank designs on paper, but could not build them reliably. The Japanese had extensive combat experience, but could not replace their losses. The Americans had nylon parachutes and the industrial capacity to produce them by the hundreds of thousands. That capacity, multiplied across thousands of products and millions of units, determined the war's outcome. The nylon parachute was not the reason the Allies won World War II. No single technology or weapon system determined the result, but it was one of countless examples of how the Allied powers, particularly the United States, could identify problems, develop solutions, and implement those solutions at scale. The ability to do this repeatedly, across every aspect of military operations, created an insurmountable advantage. When Private First Class Leonard Schroeder jumped into the darkness over Normandy on June 6, 1944, he was not thinking about industrial chemistry or supply chain management or the crisis that had threatened American airborne forces 2 years earlier. He was thinking about survival, about landing safely, about finding his unit, about accomplishing his mission. But the white nylon canopy above his head represented all of those larger forces. It represented the scientists at DuPont who developed the polymer, the workers at Pioneer who manufactured the parachute, the riggers who inspected and packed it, the quartermasters who shipped it to England, the supply sergeants who issued it, the entire vast machinery of modern industrial warfare that made it possible for 13,000 men to jump out of airplanes over enemy territory with reasonable expectation of survival. Schroeder landed safely. He fought through the hedgerows of Normandy for 37 days. He was wounded twice, evacuated to England, recovered, returned to his unit. He jumped again during Operation Market Garden in September 1944. He jumped again during the Rhine crossing in March 1945, each time with a nylon parachute. Each time the parachute brought him safely to Earth. He was one of tens of thousands of Allied paratroopers who jumped during World War II. Their survival rate was higher than predicted. Their equipment was more reliable than expected. The nylon parachutes that carried them into combat were one small but significant factor in that success. The innovation that began as a response to crisis became standard military equipment. The emergency measure became the permanent solution. The experimental material tested by Adeline Gray in June 1942 became the foundation for all military and civilian parachute manufacturing for the next 80 years. Nylon proved stronger, more durable, more reliable, and more cost-effective than silk. The crisis forced innovation. The innovation proved superior to the original material, and thousands of paratroopers descended safely into combat zones across Europe and the Pacific, carried by canopies of white synthetic fiber created in American chemical plants to solve a problem that threatened to end airborne warfare entirely. That is the true story of nylon parachutes in World War II. Not a single dramatic technological breakthrough, but a sustained industrial effort to maintain capability in the face of supply disruption. The crisis was real. The solution was effective, and the impact extended far beyond the immediate problem of replacing silk with synthetic material. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.